Good morning. In the beginning, we will discuss two sums given for homework, one of which was prove cosine rule using sine rule. Now, the first sum, the angles of triangle ABC are in arithmetic progression and B is to C is root 3 is to root 2. Find all angles of the triangle. Now, angles of triangle are in ABC. What do you mean? Are in AP rather. What do you mean by an arithmetic progression? If the difference between two consecutive terms is constant, then the terms are said to be in arithmetic progression, right? So C minus B is B minus A. So 2B is A plus C. But sum of all angles of a triangle is 180 degrees. So that gives me 2b plus b 180, that is 3b 180 degrees. So b equal to 60 degrees. Also b upon c is given as root 3 by root 2. By sine rule, a upon sine a equal to b upon sine b equal to c upon sine c. So it is b upon c from this. Rearrange the terms. It is sine b upon sine c. But it is given to be root 3 by root 2. This b upon c. So cross multiplication gives root 3 sine c equal to root 2 sine b. That is root 3 sine c equal to root 2 sine 60 degrees. So b is 60 degrees. The reason is b is found to be 60 degrees. So from this you get sine c equal to 45 degrees, right? Now a plus b plus c is 180 degrees. B and C are known. So from this, what is angle A? Angle A is of measure 75 degrees. So the angles of a triangle are what? 75 degrees, 60 degrees and 45 degrees. Now the second question was using the sine rule, prove the cosine rule. Now by sine rule, A upon sine A is B upon sine B is C upon sine C equal to K. So what is small a? K sine A, B K sine B, C K sine C. Now we have to prove cosine rule, that is to prove cos C equal to A square plus B square minus C square upon 2AB. That is to prove A square plus B square minus C square equal to twice AB cos C. We begin with LHS. A square plus B square minus C square. But from 1, A is K sine A and so on. Substitute. Now I have taken K square by 2 common so that I get 2 sine square A plus 2 sine square B minus 2 sine square C in the bracket. Why do we need 2 sine square A? Because 2 sine square A can be replaced by what? 1 minus cos 2A. Here 1 minus cos see, I have considered this term. So minus in bracket 1 minus cos 2c, right? And what is 2 sine square b? I have written 2 sine square b as it is. Now open the brackets to get cos 2c minus cos 2a. Now what is cos a minus cos b? It is 2 sine of a plus b by 2 into sine of b minus a. You have to be careful. I repeat this. Cos a minus cos b is 2 sine of a plus b by 2, that is first plus second by 2 into sine of second minus first, because I haven't begun with minus, I have begun with plus. So sine of second minus first upon 2. Is that clear? So this is k square by 2, 2 sine a plus c into sine a minus c plus 2 sine square b. Now a plus b plus c is pi. So what is a plus c? This a plus c can be replaced by pi minus b. And what is sine of pi minus b? It is sine b. That is why you will notice that I have directly written sine b. Now take sine b common to get in bracket sine of a minus c plus sine b. Now in the next step, this sine b is replaced by what? Sine of a plus c. Same reason, angle B is pi minus in bracket a plus c, sine of 180 minus theta is sine theta. Now you will notice that sine of a plus c plus sine of a minus c, this part, see the cursor, is expansion of what? 2 sine a cos c. Just check this, 2 sine a cos c is sine of a plus c plus Sine of A minus C. Yes. So I get k square sine B 2 sine A cos C. Rearrange the terms to get 2. Rearrange the terms to get 2 into k sine A into k sine B into cos C. But k sine A is A and k sine B is B. So I get 2AB cos C, which is nothing but right hand side. So we have proved cosine rule with the help of sine rule. Now we discuss important concept of inverse trigonometric functions. We know that a relation from set A to set B is called a function if each and every element of the set A is related with unique element of the set B. So here you will notice that there exists a function, say f, from set A to set B. Set A is called as domain of the function, set B is called as codomain of the function. P is called as, see the cursor, P is called as image of which element? Element A under F, and A is nothing but pre-image. Okay. Now PQR is the set of all images and it is called as range of the function. See, range is a subset of codomain. It is possible that there is an extra element, say S, in the set B, which has no association. It is allowed because what is the requirement for a relation to be a function? Every element of the set A should be uniquely associated. Is that clear? Yes. So this is about function f. Now this function is called as one and onto. Actually, there are two types of functions, one and many one. Suppose there is one more element D in set A and it is associated with R. Is that a function? Yes, it is. It is called as many one function. But clearly this is one. You will notice that this function is onto, ONTO. What do you mean by an onto function? No two elements in the codomain are the images of the same element. Means what? If I consider one more element D here, and if I say that D is associated with R, in that case R will be image. R will be image of two elements C and D, right? But this is not happening in this case. And therefore, we say that it is onto. In fact, if I include S here, actually reason is this, if I include S here, you will notice that the range of the function is a proper subset of codomain. That is, there is an element in the codomain which is not the image of any of the element. This is the reason for a function for a function to be an into function and not an onto function. Now, in this case, you will notice this function is now one, but not onto, it is into. In this case, you will notice that function from set B to set A does not exist. Why? Because what is the criterion? Criterion is every element of the set B should be uniquely associated with an element of the set A, but S has no association, right? So if the function is into, then function from B to A does not exist. Now I remove this element. Now the function has become an onto function. So if the range is nothing but codomain itself, then the function is an onto function. As function from A to B is one and onto, there exists a function from B to A. It is also one and onto, but it is called as inverse of the function. We write this as f raised to minus 1, but we have to read this as f inverse. Clearly, for f inverse and f, the domain and range are interchanged. For example, in this case, for the function f, domain set A, range, that is codomain set B. For f inverse, domain is set B and range, that is codomain, is set A. Is that clear? Now you will be surprised to know that the trigonometric functions are not 1 1 and onto. I mean, they are onto their ranges, but they are not 1 1. For the simple reason, all the trigonometric functions are periodic functions. We have done this. Tangent function and cotangent functions are periodic functions with fundamental period pi. Remaining functions have fundamental period 2 pi. So these 6 trigonometric functions, they do not possess inverse as it is. For that, we have to restrict the domain of these functions. The functions are already onto their ranges, but with restricted domain they become 1 1 also, so that their inverse can be obtained easily. Let us discuss that. Basically you should know about this part, at least about sine, cosine and tangent. For the sine function, what is domain? It is R. What do you mean by domain? If I say sine x, then set of all values which can be assigned to x, that is angle. That is the domain. So domain is set of real numbers, means sine ratio of any real angle is defined. What is the range? Range is set of all values of sin x. The maximum value of sin x is 1, minimum value is -1. So we say range is, this is closed interval. What do you mean by closed interval? So in that case, extreme values, they belong to the same interval. So this is the range. Now the values of sine function, they repeat after 2 pi radian, I mean. So the period of sine function is 2 pi. What about cosine function? Again, domain is set of real numbers and the range is closed interval -1 to 1. Period is 2 pi. We know that tangent ratio of angles like pi by 2, 3 pi by 2 are not defined. So what is the domain for tangent function? All real numbers except, how will you describe this? Odd integral multiples of pi by 2. Pi by 2 means 90 degrees. 2n is always even, 2n minus 1 is always odd. So all real angles except odd integral multiples of pi by 2. That is the domain of tangent function. Now tangent ratio can assume any real value. So this is the range. What is the period of this function? Pi. Cosecant function, cosecant of which angle is defined? All real angles except integral multiples of pi. For the simple reason, see, what is sine 0? 0. So as sine 0 is 0, its reciprocal cosec 0 will not be defined, right? And what is the range of cosec function? All real numbers except open interval -1, 1. Why open interval here? Because cosec theta can be 1, right? Sine 90 degree 1, so cosec 90 degree is also 1, and that is why period is 2 pi. Similarly for secant function and cotangent function. So you have to remember this table. Inverse function of f of x equal to sin x. Let f of x equal to sin x, where x is any real number, because sine ratio of all real angles are defined. The graph of this function from x equal to -2 pi to x equal to 2 pi is shown below. The range of this function is the closed interval -1, 1. Why? Because the maximum value of sine ratio is +1 and the minimum value is -1. Okay. This function is therefore onto -1, 1, but it is not 1, 1. Why? Because what is sine pi by 6? Sine pi by 6 is same as sine 5 pi by 6 is same as sine 7 minus 7 pi by 6, which is nothing but 1 by 2. See, if you draw a line which is parallel to the x-axis and if it is intersecting graph in more than one point, clearly that function is not 1, 1. See, if you draw a line like this, you will notice that line intersects the graph at so many points. Okay. Yes. So the function is definitely onto, but it is not 1, 1. So we can say that it is clear that the inverse of this function does not exist. Now next part is important. Now if we restrict the domain of this function as the closed interval minus pi by 2 pi by 2. See this dark part. This is minus pi by 2 means minus 90 degree to plus 90 degree. You will notice that as far as this part is concerned, if you draw a line which is parallel to x-axis, then it does not intersect the graph in more than one point. That is, the function is 1, 1 in this restricted domain. So if we restrict the domain of this function as the closed interval minus pi by 2 pi by 2 shown by the dotted lines in the figure, then the function is 1, 1 and onto closed interval minus 1, 1. In this case, the inverse of this function exists with domain minus 1, 1 closed interval and what is the range? Closed interval minus pi by 2 to pi by 2. This inverse function is denoted by sine inverse x. Thus, y equal to sine inverse x if x belongs to closed interval minus 1, 1, y belongs to closed interval minus pi by 2 to pi by 2, and we can very well invert the relation y equal to sine inverse x if x is sine y. Is that clear? So for the function y equal to sine inverse x, this is the domain and this is the range. Also, it is clear that y equal to sine inverse of sine y. We have already used this result in derivatives. Sine inverse of sine of any angle is that angle provided the angle belongs to the particular range. Similarly, sine of sine inverse x is always x provided x belongs to this closed interval minus 1 to 1. Now this part is again important. As explained above, we restrict the domain to close interval minus pi by 2 to pi by 2 to make the sine function 1, 1 and onto. But this is not the only interval in which the sine function is 1, 1. The other such intervals are pi by 2, 3 pi by 2. See, this pi by 2 to 3 pi by 2. Can you see this? See this part. No two angles have the same sine ratio if I consider pi by 2 to 3 pi by 2. Is that clear? Or even minus 3 pi by 2 minus pi by 2, 3 pi by 2 to 5 pi by 2, etc. Hence, we can also define inverse sine function for all such intervals. Corresponding to each such interval, we get a branch of inverse sine function, that is sine inverse minus 1, 1 to pi by 2 to 3 pi by 2 and so on. But next part is important. Out of these branches, the branch with range close interval minus pi by 2 to pi by 2 is called as the principal value branch. We are interested in principal value branch only. Means what? Suppose I ask you, what is sine inverse 0? You should not say pi. Sine inverse 0 is pi is wrong, because your answer should belong to closed interval minus pi by 2 to pi by 2, because we are considering this as principal value branch. So there are so many angles having sine ratio 0, but we are interested in that angle which belongs to this particular interval. So what is sine inverse 0? Sine inverse 0 is nothing but 0. Now from this, can you tell me what will be sine inverse minus 1 by root 2? Type your answer in chat box. My question is, what will be sine inverse minus 1 upon root 2? See, I ask you to find value of sine inverse minus 1 by root 2. Some students are saying like 225 degrees, etc. Basically, answer should be given in terms of radian. But anyways, angle in degree can be converted to angle in radian. See, I already told you that answer should belong to this closed interval. Suppose that angle is x. Now invert the relation. So minus 1 by root 2 is sine x. Now tell me the angle whose sine ratio is minus 1 by root 2 and which belongs to this particular interval. Clearly that angle is minus pi by 4. Right? So what is sine inverse of minus 1 by root 2? It is nothing but minus pi by 4. Now inverse function of f of x equal to cos x. Let fx be cos x belongs to set of real numbers. Its graph from x equal to minus 2 pi to x equal to 2 pi is shown below. See, cos 0 is 1, cos pi by 2 is 0, cos pi is minus 1, then cos of 270 degrees 0, cos of 360 degrees 1, and so on. Clearly, this function is onto minus 1 1. I repeat this. What do you mean by onto minus 1 1? Consider any real angle, its cosine ratio definitely lies between minus 1 and 1, both inclusive. That is why it is always onto minus 1 1. But it is not 1 1. How to know that? See, draw any line parallel to x-axis. If that cuts the graph in more than one point, then that function is not 1 1, it is many 1. So there are many angles whose cosine ratio is the same. Okay. So this function is also onto minus 1 1, but not 1 1. Now if we restrict the domain of this function as closed interval 0 to pi, see, cos 0 is 1 and cos pi is minus 1. So if we restrict the domain as closed interval 0 pi, then it becomes 1 1. It is already onto. So now the function is 1 1 and onto. So in this case, the inverse of this function exists with domain closed interval minus 1 1 and the range closed interval 0 to pi. This function is denoted by cos inverse x. So for cos inverse x, what is the domain closed interval minus 1 1 and what is the range closed interval 0 to pi? We can invert the relation as x equal to cos y. So same is written in this form. For cos inverse x, this is the domain and this is the range. It is clear that y equal to cos inverse of cos y and x equal to cos of cos inverse x. Same logic, we can also define the inverse cosine function for the intervals pi to 2 pi or minus pi to 0 or 2 pi to 3 pi, etc. Out of these intervals, the branch of cos inverse defined for closed interval 0 to pi is called as the principal value branch. This is very important. Now try to answer this. See, y is cos inverse x. Y belongs to closed interval 0 to pi. That is, your answer should belong to this particular interval. I asked what is cos inverse root 3 by 2. You can say let this be y. So cos y is root 3 by 2. Can you tell me the angle whose cosine ratio is root 3 by 2 and that angle belongs to this interval? Yes, it is nothing but 30 degrees. But instead of degree, you have to say pi by 6 radian. Now cos inverse minus half. Some students have written minus pi by 6. No, see, cos of minus theta is basically cos theta, right? So how can you say minus pi by 6? And again, your answer should belong to this interval. Now you should know that cos of pi minus theta is nothing but minus cos theta. So it is cos inverse minus half. It is cos of 180 minus 60. That is 120 degrees. What do you mean by 120 degrees? It is 2 pi upon 3 radian. See whether 2 pi upon 3 belongs to this interval or not. Yes, it does. Right? So it is cos inverse minus half. It is not minus pi by 6. It is 2 pi by 6. I'm surprised to read that cos inverse root 2 is somebody is saying 45 degrees and so on. This is absurd. Cos inverse root 2 is absurd because root 2 is greater than 1 and cosine ratio has to lie in closed interval minus 1 1. In other words, for cos inverse x, what is the domain? Closed interval minus 1 1. So cos inverse root 2 is not defined. This is absurd. Is that clear? Now inverse function of f of x equal to tan x. Let fx be tan x. We know that the tangent function is not defined if x is an odd integral multiple of pi by 2. That is, its domain is all real numbers except odd integral multiples of pi by 2. Now graph of the function from minus 2 pi to 2 pi is shown below. See, the graph does not intersect this line x equal to pi by 2, x equal to minus pi by 2 and so on, because tan pi by 2 is plus infinity, we can say, means not defined. Similarly, tan of minus pi by 2 is not defined. Its range is R and it is onto R but not 1 1. Why? Because there are so many angles whose tangent ratio is the same. Again, I'll tell you the same logic. If you draw the line parallel to x-axis and if it cuts the graph in more than one point, clearly that function is not 1 1, it is many 1, right? If you consider x-axis itself, there are so many points, minus 2 pi, minus pi, 0, pi, 2 pi, all these angles have the same tangent ratio, which is 0. Is that clear? So its range is R and it is onto R but not 1 1. Now if we restrict its domain as the open interval minus pi by 2 to pi by 2. See, why open interval? Because tan pi by 2 and tan of minus pi by 2 are not defined. See, consider the open interval minus pi by 2 to pi by 2. In this case, draw the line parallel to x-axis. You will notice that it doesn't intersect the graph in more than one point. So the function has become 1 1 also. From the beginning it is onto R, but it has become 1 1, right? So in this case, the inverse exists with domain R and range open interval minus pi by 2 to pi by 2. This inverse function is denoted by tan inverse x. Thus y equal to tan inverse x if x is real number and y belongs to open interval minus pi by 2 to pi by 2. In this case, we can say invert the relation to get x equal to tan y. So for the function y equal to tan inverse x, domain is set of real numbers. And what is range? Set of all angles, open interval minus pi by 2 to pi by 2. It is clear that tan inverse of tan y is y and tan of tan inverse x is nothing but x. Note, the inverse tangent function can also be defined for the intervals pi by 2 to 3 pi by 2 open interval or minus 3 pi by 2 to minus pi by 2. Out of these, the branch of tan inverse defined for minus pi by 2 to pi by 2 open interval is called as principal value branch. Now my question is, what is tan inverse root 3? The correct answer is pi by 3, because tan pi by 3 is root 3. What is tan inverse minus 1 by root 3? There are so many angles having this tangent ratio, but answer should belong to this open interval. So correct answer is minus pi by 6, that is minus 30 degrees. Tan inverse 0, 0. So these are the answers. Actually, after this, we should discuss cosecant, secant and cotangent function, but we will do that part after a few lectures. Now we will solve few sums from exercise 3.3. Then of course we have to discuss about graphs of inverse trigonometric functions also. Exercise 3.3. First question, find the principal values of the following. First part, sine inverse half. Now the principal value branch for sine inverse x is what? Closed interval minus pi by 2 to pi by 2. Let sine inverse half be alpha, where alpha belongs to this closed interval. Invert the relation. So sine alpha is half, but sine pi by 6 is half. Actually, there are so many angles having same sine ratio, but I have to see that that angle belongs to this particular interval. So that is pi by 6. So alpha is pi by 6 as pi by 6 belongs to this. So final answer is principal value of sine inverse 1 by 2 is nothing but pi by 6. Second, the principal value of for cosec inverse 2. Now you may say that cosec inverse 2 is sine inverse half. That is true, but here I have considered cosec inverse as it is. Remember, PVB is not the standard short form. You have to write principal value branch of cosec inverse x is what can be remembered easily. Close interval minus pi by 2 to pi by 2 except 0. Why? Because cosec 0 is not defined. Sine 0 is 0, so cosec 0 is not defined. Okay. So all angles in this interval except 0. Let cosec inverse 2 be alpha. Invert the relation. So cosec alpha is 2. Now sine pi by 6 is half. So cosec pi by 6 is 2. Is that clear? And pi by 6 is valid because it belongs to the desired interval. So what is the principal value of cosec inverse 2? It is pi by 6. Third one, the principal value branch of tan inverse x is what? Open interval minus pi by 2 to pi by 2. You have to be very careful. Please do not say close interval because tan pi by 2, tan minus pi by 2 are not defined. Let tan inverse minus 1 be alpha. Invert the relation. So tan alpha is minus 1. But 1 can be replaced by tan pi by 4. See, our answer should lie in this interval only. Now what is tan of minus theta? Minus tan theta. So I can say that minus tan pi by 4 is tan of minus pi by 4. So can I say alpha is minus pi by 4? Yes, I can, because this belongs to open interval minus pi by 2 to pi by 2. So what is the principal value of tan inverse minus 1? It is minus pi by 4. Fourth and fifth for homework. Answers are given. Now sum number 6. We are asked to find cos inverse minus half. What is the principal value branch of cos inverse x? Close interval 0 to pi. Let cos inverse minus half be alpha. So invert the relation. Cos alpha is minus half. But cos pi by 3 is half. So it is minus cos pi by 3. You should know that cos of minus theta is not minus cos theta. So what is minus cos theta? It is cos of pi minus theta. You may say cos of pi plus theta is also minus cos theta, but the angle has to lie between 0 to pi, and that is why I have written minus cos pi by 3 as cos of pi minus pi by 3, which is 2 pi by 3. So alpha must be 2 pi by 3. Again verify whether it belongs to this interval or not. Yes, it does. So what is the principal value of cos inverse minus half? It is 2 pi by 3. Second question, evaluate the following. First part, tan inverse 1 plus cos inverse half plus sine inverse half. If this is asked for 2 marks, then you should write at least this much. Let tan inverse 1 be alpha, where alpha belongs to open interval minus pi by 2 to pi by 2. So what is tan alpha? 1. But tan pi by 4 is 1. You have to see that pi by 4 belongs to this interval. So clearly alpha is pi by 4. That is tan inverse 1 is pi by 4. Similarly, cos inverse half beta, cos beta is half, but cos pi by 3 is half, and pi by 3 belongs to this interval. So beta is pi by 3. Similarly, sine inverse half is nothing but pi by 3. Now just add them. So what is tan inverse 1 plus cos inverse half plus sine inverse half? Pi by 4 plus pi by 3 plus pi by 6, that is 3 pi by 4. Now second, third and fourth for homework. In the second sum, actually cos inverse half is pi by 6, and what is sine inverse, I'm sorry, cos inverse half is pi by 3, and what is sine inverse half? Pi by 6. Add them to get 2 pi upon 3. If you see the third one, then actually we can find the values orally. Tan inverse root 3 is pi by 3, And secondly, sec inverse minus 2 is basically cos inverse minus half. What is cos inverse minus half? It is 2 pi upon 3, but we are asked to find the difference between them. See, I haven't written sec inverse minus 2 as minus 2 pi by 3. It is 2 pi by 3 only. The only thing is where to find the difference. So this is the answer. And in the last part, what is cosec inverse minus root 2? It is basically sine inverse minus 1 by root 2, that is minus pi by 4. Okay. And second part is cot inverse root 3, means tan inverse 1 by root 3, which is pi by 6. Their addition is asked, so it is minus pi by 12. So that's it for today.